Okay, good morning class. So today we're looking at sequence and series. So today we're looking at sigma notation. So at this point we spoke about sigma notation, and we said that stands for the sum of, and more importantly that in the sigma here, this value here will always be your starting point, your ending point, your general term, and with the asked to evaluate, to determine or simplify, it would then require you to work out the sum of terms. Okay? Then we counted. How do we actually know the number of terms in the series? We say it's the ending point minus the starting point plus 1. It's vitally important to remember, or is of importance to remember. Okay? People are looking at the example on page 18. Make this a bit bigger. You can see clearly what the question is. This is work example 1 on page 18. This is for exercise 8 on page 20. Right, so here it says evaluate. Where do we start? We start where n is equal to negative 4. Where do we end? 20. And this here we see this out. What is this? The general term. Not so. So how many terms are here in the series? Okay, I gave you that formula. N is equal to the end point minus the starting point plus 1. What is the end point? 20. Minus negative 4 plus 1. So they give me an answer. So there are 25 terms in the series. Okay. People, there's one of two ways I can do this. I'll do both with you. I can work out the first 3 terms. I'm not going to go with the last term story, okay? I'm going to work out the first 3 terms. So I will just work out the first 3 terms. Where do we start? Where n is? Negative 1. So this is going to be 5 times negative 4 minus 2, which is negative 22. You all agree with that? Right. Then we go term 2. Where do you go for term 2? What's your end value now? Negative 3. We said we're going to do that in increments of 1. So it's going to be negative 4, then negative 3, then negative 2, then negative 1, and so on. So term 2, your end value is now negative 3. So it's 5 into negative 3 minus 2, which is negative 17. For term 3, it's going to be 5 multiplied by negative 2. Remember, we're starting at negative 4, then negative 3, negative 2, and so on. Minus 2, which is negative 12. So my formula I'm going to use here is Sn is equal to n over 2 into 2a plus n minus 1. Why am I going to use this formula? Because sigma stands for the sum of. Okay. So what's the value for n? So it's S25 is equal to 25 over 2 into 2 times negative 22 plus 25 minus 1, which is 24 times. How do I move from one term to the next? You're adding 5. This times 5. Let's use this formula quickly. Substitute the calculator, so it's 25 over 2 into 2 times negative 22 plus 24 times 5. Then answer of 950. Okay? People, if I had used the other formula, what is the other formula? Sn is equal to n over 2 into a plus l. It's going to be easier to use this formula. Remember, I've calculated n already. So irrespective which formula I'm going to use, I need to calculate n. Okay? So, if I worked out a is my first term, not so. And what's the first term? 5 times negative 4 minus 2, which is negative 20. What's the last term? The last term is going to be where n is 20. Not so? So your last term is going to be 5 times 20, which is 100, minus 2, which is 98. Using that formula is 25 is equal to 25 over 2 into negative 22 plus 98. That's going to give you 25 over 2 into negative 22 plus 98 to 950. Of course, it must give you the same answer, not so. Because if you use any method, it should give you the right answer provided you need to make a mistake. Must I do both in the exam? No, you do one of the two. Okay. Sorry? 950. Did I make a mistake?
Yes, sir.
I wrote it down wrong. Okay. Thank you, my girl. 950. Okay. Any confusion here? No? Let's carry on. This is now the second example, and this is on page 19. Example 2 on page 19. Example 2 on page 19. Here we asked to evaluate. You're starting at 1 and you're going all the way to infinity. So what rings the bell? It's infinity. Not so. What is this to us? N. Okay. So what I'm going to do now is I'm going to work out my first 3 terms. Okay, you'll see me do that often. I always work out my first 3 terms. Okay, so where do I start? I start where n is 1. So for term 1, it's simply going to be 3 into of 1 minus 1. Not so. What would it be for term 2? 3 into of, what is n now? 2. And 2 minus 1. Not so. For term 3, what would it now be? 3 into of 3 minus 1, and so on. 3 is enough for me. Okay, 3 terms. So the first one works out to be that n to the power of 0 is 1. So it's going to give you 3 times half, which is 3 over 2. That is 3 squared, which is 3 over 4, and so on. Okay. Am I moving too fast? No. So what is the formula for sum to infinity? A over 1 minus r. What is my a value? 3. So it's going to be 3 over 1 minus. How do I calculate r? How do I move from one term to the next? Multiplying it by r. Or you can say 3 over 2 divided by 3 will give you r value. So it's minus r. So it's going to be, the answer should be 6, I think. Okay, so it's 3 over 1 minus r. Yes. Okay. What does that mean to say? If I extend this term, the series, all the way to infinity, and I add up all those values, you'll see the series will, what's that word I used yesterday? Converge. It will tend to that point of 6. It will come very close, it's almost 6. Okay. You guys understand? Okay. Let's get on with our lives. Example 3 is on page 19 as well. And this is for examples for exercise 8, which is on page 20. People, if sigma r is equal to 1 to n terms. The general term of a half into r, a half into 3 to the r minus 1 is equal to 1640. Determine the value of n. So what am I calculating here? I'm actually calculating the n, which is what? Number of terms. In other words, we're calculating the number of terms. We're calculating n here. Okay. So where do we start? We start with calculating the first 3 terms. So let's go with term 1. Term 1. Term 1. Let's start with r is 1. So what will that be? It will be half 3 to the 1 minus 1. Not so. Term 2. What will term 2 be? Half 3 into the exponent 2 minus 1. Term 3. Half into 3 minus 1 and so on. So this would simply be a half. This would be, isn't it the same as the previous one? Oh, I could have just taken it. No, it's not. It's not. It looks similar. Okay, plus. The next one is going to be 9 over 2 plus and so on. So from here, what can I derive? I can say that my A value is, from here I can derive that my A value is of, what's my R value? It's going to be 3 over 2 divided by half, which is, how do I move from one term to the next? Times it by 3. So 3 over 2 divided by half is 3. Or 9 over 2 divided by 3 over 2 is 3. How many terms are here? How do you work out the number of terms? You say the end point minus starting point plus 1. What's the end point value? N minus starting point 1 plus 1. So in other words, the number of terms in the sequence is actually n as well. However, if you had started at r is 2, then it would have been n minus 2 plus 1. So the number of terms would have been n minus 1. You understand? So just play around with that thing. What other information do we have? Remember, this is my starting point, this is my ending point, this is my general term which I just worked with now. What does this tell us? So that means to say the sum of the series is equal to 1640. Not so. So how can we calculate n in that case? If Sn is equal to 1640. Sorry? Use that formula. So it says n over 2 into 2a plus n minus 1d, or Sn is equal to n over 2 into a plus. You all agree with that? When do we use that formula? Arithmetic. Is this arithmetic? No. But you have the right idea. But you must use a geometric formula. The geometric has two formulas, sum to infinity and Sn. Which one of the two are we going to use? Sn. Why? Because it's not going to infinity. It would have been infinity on top, then I would know, okay, use that infinity formula. So what's the formula? Sn is equal to a into Rn minus 1 over R minus 1. Or you could have said Sn is equal to a into 1 minus R to the n over 1 minus R. The same thing. Alright. So remember, what are we calculating? We're calculating n. As we said, this is Sn. So we now can say 1640 is equal to a, which is half, into 3 n minus 1 over 3 minus 1. What's 3 minus 1? 2. So I'm going to cross multiply by 2. So it's going to be 3,280, I think. No? Okay, now what? Divide by half. So it's 6,560 equals 3 to the n minus 1. Now what do I do? Take the 1 over. So 6,561 equals 3 to the n. So I'm sure that number can be written as 3 to some exponent. Okay, so it's going to be 6561 equals shift factor. Shift factorize is 3 to the 8. So that, what does that mean? That means to say, therefore, n is equal to, there's 8 terms in the series. Okay. So, all okay still? Alright, let's carry on. The full lesson, of course, can be found in the description box below. Okay. People, we are on page 20 now. The work examples on page 20. Example 4. So now we are told that evaluate each of the series below and express the result in sigma notation. Sigma notation. Okay. Let's refresh your memory again. Sigma, this is your starting point, ending point, general term is equal to sum of terms. So that's the format they want you to write it in. Okay. So first I need to calculate my general term. Not so? So looking at number 1, the general term would be Tn is equal to a plus n minus 1t. What's my a value? Sorry? 12 plus n minus 1 term. What's your d value? How do I move from one term to the next? Subtracting 8. So it will be 12 minus 8n plus 8. So it's negative 8n plus 3. That's my general term. Okay? So we got negative 8n plus 20. Since it's more than one term here, I put it in a little bracket. Okay. People, if we write this ourselves, we always start with k is equal to, or n is equal to 1. We don't complicate our lives, okay? Our lives is enough complicated already. Not so? So what must go on top? The number of terms there are in the series. Not so? But where do I get that? The number of terms in the series? I go to the last term, that is t. Okay. So what do I say? Did the general term equal? Negative 276 is equal to negative 8n plus 20. Is negative 296 is equal to negative 8n. So 8n works out to be 36 or 7. 296 divided by 8, 37. Nice. You guys understand? So here goes 37. But what must go here? The sum of the series, not so. So now we say Sn, which one am I going to use? The first one or the second one? Second one. Why? Sorry? We have the last term. So Sn is equal to n over 2 into a plus l. So we're going to work out the sum of 37 terms. So it's 37 over 2 into, what's my first term? Sorry? 12 plus negative 276. Or I could have just written negative 276. So it will give 37 over 2 into 12 minus 276. It's negative 4,884. Okay. Okay? Wanna carry on? This is the first one. Let's look at the second one, number 2. Okay. Okay, let's look at number 2. For number 2, we got 100, 40, 60. So how do I move from one term to the next? Sorry? You're minusing 66. So I'm minus 60 here? Am I minusing 60 there? No, so I'm not minusing 60. Sorry? You're halving. Sorry? Okay. T2 over T1. There's 40 over 100, which is 2 over 5. We're multiplying it by 2 over 5. 40 times 2 over 5? 16. You sure? Yes. Remember the question says you must express this in sigma notation. Right. So I must work out my general term. So my general term is Tn is equal to A plus A on n minus 1. What's my A value? 100 into R 2 over 5 raised to the exponent n minus 1. Okay, that's my general term. So I can start filling in this information. So where my starting point will be n is equal to 1. Okay. Is there a way of calculating my last term? Or the number of terms in the series? No. What else do we notice? 2 over 5 is also between which two values? Negative 1 and 1. So what type of sequence is this? Sum to infinity. Or convergent series. Okay? So that goes to infinity. The general term is 100 into 2 over 5 raised to the n minus 1. Can I multiply these numbers here? Why not? On an exponent. Okay. And this is equal to the sum of. So I must still calculate the sum to infinity. So what's the sum to infinity formula? A over 1 minus R. What's my A value? 100 over 1 minus 2 over 5. So it's 3. It's going to give me 5. 500 over 3, I think. 500 over 3. Let me just check a quick way around. 100 over 1 minus 2 over 3. Oh, 5. It is. Yep, 500 over 3. And that is now equal to 500 over. Any questions, people? Sum like this is what? 5 marks. 4 or 5 marks. The previous one definitely 5 marks. The sum to infinity was a bit easier. Less work. So 4 marks. Okay. Any confusion here, people? See how easy grade 12 is? Huh? People, let's look at number 3. For number 3, we got 5 minus 10 plus 20 minus, the last answer is 5120. So if there's no sign there, assume the sign is positive. Okay. Right, where do we start? The sigma. What's my starting point? Huh? N is equal to 1. General term we're going to work out first. Okay. People, how do I move from one term to the next? So negative 10 over 5, no? Which is negative 2. So I'm multiplying it by negative 2 all the time. So what type of sequence is this, or series? Geometric. Okay. So what's the general formula for geometric sequences? Tn is equal to AR n minus 1. What's my A value? 5. R negative 2 n minus 1. So that's my general term. 5 into negative 2 n minus 1. I have my last term. Not so? So I can work out my number of terms here. Okay? So what do? I say 5 120 is equal to 5 into negative 2 n minus 1. So what do now? Divide by 5. So negative 2 raised to the n minus 1 is equal to. So you say if 5120 divided by 5 is just 1024. 1000. People, for the basis to be the same, the exponents must be. For the exponents to be the same, the bases must be equal. No? When bases are the same, exponents are equal. I don't know how to split it down. Or did I say it wrong? Okay, my mistake. So I need to make this base the same. Not so. But for this to be a base of negative 2, you see this is positive here. Then what must the exponent be? It must be even. Not so. So if the exponent is even, this number will be positive. Okay? So we say 1024, shift, factorize. What? 1024. 104. No, that's not no. 5120 divided by 5. 1024. I was thinking of the even exponents here. Right. I press shift, factorize. It's 2 to the 10. And that confirms my what we just said now. This has to be even. Okay. So when bases are the same, exponents are equal. So therefore, n minus 1 is equal to 10. So n is equal to 11. Where am I starting? N is equal to? And this must be equal to what? She says 5,120, is that correct? What must come here? Sn. What is this? Last term, Tn. You guys understand? Don't get confused, no? So what's my formula? Sn is equal to n over 2 years, don't be shy, into which one of the two formula I'm going to use? A plus L, you all agree with that? Yes. No. What type of sequence is this? Geometric, yes. What kind of number? You see why Fridays aren't good for you? Right. What's my formula? A into R, yes, over R minus 1. So imagine I gave you a class test. Everybody can do the test together. Now open book and whatever. You guys are going to use the wrong formula. No? So none of you are saying the right thing. How much I feel? Right, people, what's your A value? 5 into. What's your R value? Negative 2. How many terms are here? 11. Minus 1 over negative 2 minus 1. So this will simply be open 5 open brackets, another bracket, negative 2 to the exponent 11 minus 1 over minus 2 minus 1. 3,415. Okay. Any confusion here, people? Okay, so this take is off. Number 1. You look at number 2. Sorry, number 3. You look at number 4. So here we're starting with 1, 4, 9, 16, 25, 36, 40. People, what does that remind us of? What do you notice about that? Square numbers. Yes! So what's a general term then? Yeah. So that goes there. Where do I start? N is equal to 1. How many terms are there? 7. What is that equal to? What? Sn. You're going to use the Sn formula. Alright, let's see. Which one of the 3? N over 2 into A plus L. Do we have the last term and the first term? Yes. Is it arithmetic? No. So can I use that? No. N over 2 into 2A plus N minus 1D is also arithmetic. This arithmetic? No. The geometric formula. Sn is equal to A into R to the N minus 1 over R minus 1. Is this geometric? No. Can I use that formula? No. So what are we going to do? You just, there we go. You just add the numbers. Simple. Because all the numbers are there, it doesn't make life difficult to just add them all up. Okay. So that's going to give us 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. Is an answer of 100 Okay. So that's it, people. That's my story for the day. For homework, I would like you guys to do exercise 8 on page 20. Okay. With that, I would like you guys to do from the revision test topic on page 29. We do number 1, 2, 5, 4, 6, and 8. You guys give it again. It's 1, 2, 4, 5, 6, and 8. People, enjoy the rest of your day. Good morning, class. The full lesson can be found in the description box below.